Hello, hello, hello. Welcome to part 2. I actually just finished part 1, just moving on to part 2. Just want to get this done. I think I might probably take a nap after, or grade tests, whichever, I feel like. Okay, number 20. State the domain and range of the relation. So this is like the same thing. The difference is that I have to recognize how to find the domain and range from a graph rather than from a set of ordered pairs. So the domain is going to be the x's. So I'm just going to put little lines underneath the ones that have points. So that's 1, 2, 3, 4, 6, and 7. 1, 3, 4, 6, and 7 is the domain. 1, 3, 4, 6, and 7. And then we'll do the same thing for the y values. So 0, 2, 4, 5, and 7. 0, 2, 4, 5, and 7. Alright, let's fix this terribly messy comma. And that's all that is. Okay, find the constant of variation k of the direct variation. Well, I should know y equals kx is a direct variation. Notice that is solved for y. So take what they gave you and solve it for y. And if it's bothering you that the y is on the, quote, wrong side, unquote, rewrite it. Use the symmetric property even. All right, divide both sides by 15, so y is equal to, 5 goes into 15 3 times, negative 1/3 x. That's the same thing as negative 1/3 x. Remember, the x can come off and just sit right next door to the number, the coefficient. So k is negative 1/3. And then solve for n, as in Nancy. So in this equation, you've got a fraction to deal with. And you've got a constant to deal with. Let's get rid of the constant first. So m minus 17 is equal to 3/7 of n. Multiply both sides by 7/3. And you can leave it 7/3 times the quantity m minus 17. And we did that, remember, because any number times its reciprocal. Any reciprocal times its number. Any number times its reciprocal is 1, and we wanted 1n. If you do distribute, just make sure you express it as a fraction because there was a fraction in the original problem. Okay, I shouldn't say it as a fraction. Express the numbers in your answer as fractions. Number 23, a line that falls from left to right has what kind of slope? Negative. Find the slope of the line represented by the equation x plus 4y equals 3. Let's do that. Well, in order to do that efficiently, what we're going to do is solve for y. So I'm going to subtract x from each side, making it 4y equals negative x plus 3. And I'm going to divide both sides by 4 to give me y equals. Now, what is the coefficient of this x? Well, it's negative 1/4. I should recognize that x has a negative 1 in front of it because it has a negative sign and no other, no other visible number. And then I have the 3 over 4, so 3/4, which doesn't actually matter because they wanted the slope. So negative 1/4 x. Be very careful that you don't try to say that it's negative 4. Find the equation of the line of a line with a slope of 3 that contains the point negative 4, 6. That's the same thing we did a few minutes ago. So let's do it again. Let's do point slope form again. I think it was even this color on that slide too. And I like to try to write the formula down before I plug in the numbers so I can avoid making careless mistakes. I'm good at careless mistakes. Notice it was minus negative 4, so I made it x plus 4. 3x plus 12. Add 6, add 6. Y equals 3x plus 18. All right, number 26. For number 26, you're plugging in the 2/5 for x. And in this case, I'm going to square the fraction by squaring the top, squaring the bottom. This is going to be minus 2 plus 1. So 4/25 minus 50/25 plus 25/25. If I don't have a fraction, I've got to be able to improvise. Improvise, not impromise. There's no such thing. Okay, so 4/25 minus 50 over 25. Now remember where I got that. If that's 2 minus 2, 50 over 25 is equal to 2. So 4 minus 50 is negative 46, plus 25 is negative 21 over 25. Okay, and actually, since I'm really not interested in making another slide for just one problem, let's go ahead and do this one with the radicals, the square roots and stuff right here. So negative 4 times the square root of a is 49, plus 2 times the cube root of b, which is 27. Well, that's negative 4 times 7, plus 2 times cube root, remember, is what to the third power equals that? So the cube root of 27 is 3. So negative 28 plus 6 is negative 22. So you should get negative 22 for number 27. Okay. 28. Given the system of equations, find the value of y in the solution. I know it just says y, but make your rule to go ahead and always solve to the end of a system. That way, if you do end up making a mistake when you go back to check it, you'll already have both variables, just in case. Just in case. He must be an insurance agent. Har, har, har. Okay, I use substitution. Why did I use substitution? Because one of them is already solved for y. So why not plug it in and use it? So 5x minus 6x plus 3 equals 8. So negative x plus 3 equals 8. Subtract the 3. Negative x equals 5. And x equals negative 5. Y equals negative 2 times negative 5 plus 1. So 10 plus 1, which is 11. And my ordered pair is negative 5, 11. And we can double check that by doing the math to plug it in and work backwards. So when I plug in negative 5 to that first equation, of course I get 11 because that's how I got the y value, was plugging in the negative 5. But let's check the other one. 5 times negative 5 is negative 25. Negative 25 plus 3 times 11 is 33. Negative 25 plus 33 is indeed 8, so I know it's right. Number 29, write the equation of a vertical line that passes through the point negative 2, 7. So, vertical lines, okay, we have the acronym, the Rankine-created acronym, HOI, VUX. So, horizontal lines have a zero slope, have a y-only equation. Nope, not what I'm dealing with. Vertical, x-only equation. Undefined slope, who cares about that? What does x equal in this? That's the part where we get stuck, right? Well, look at the ordered pair. You have an x. This is the vertical line that contains every point where x is negative 2. So it has to contain this point where x is negative 2. Number 30. Find the equation of the inverse variation shown. Inverse variations are y equals k over x, but you're not finding that organically. You're not just going to pull that k out of thin air. Think about what k is when we have it solved for k. And that seems to be something we do pretty much every time we do a direct or an inverse variation. Solve for k. Well, if you plug in that first ordered pair, 3 times negative 6 is negative 18. And since it tells me it's an inverse variation, I don't need to worry about writing out any more of that. The solution to the problem, or the answer to the question, find that equation is y equals negative 18 over x. To confirm that that's right, I can look at this ordered pair and realize 2 times negative 9 is indeed negative 18, and negative 4.5 times 4 is indeed negative 18. Number 31 is a regression problem. If you would like to review regression, please, 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 if we have school, I don't like saying that out loud, Monday, when we have school Monday, let's go with that, come and see me before school starts and we will review regression, if you are so concerned. But remember that you get a table. Your x's are going to be the top row in the table. Your y's are going to be the bottom row in the table, unless otherwise specified. You're going to go to Stat on the graphing calculator, edit, and then enter your lists, x's into list 1, y's into list 2, and then it's Stat, and then calc, and it's linear regression, which is number 4. And when you calculate it, write the equation down, and then in this problem, we're plugging in this for x, because that's an x value. Home stretch. Given the function shown, find the x and y intercepts of this function. Well, first of all, the confusing part with that is, but there's no y. Remember, y is equal to negative 6x plus 4. So that's the same thing as f of x equals negative 6x plus 4. And the y-intercept is easy because that's already in the equation. That's b, that's this constant, that's 4. To find the x-intercept, plug in the 0 for y. I'm going to jump down to here where I have a little more space. And solve. So I'm going to add 6x to each side. I get 6x equals 4. When I divide by 6, I get x equals 2/3. So the x-intercept is 2/3. Number 33. Find the equation of the line that passes through the points negative 5, 4, and 3, negative 2. Let's start by finding the slope of our line. Y minus y over x minus x. 7 over negative 7 is negative 1. Now I can use one of my two formulas. Let's use the one I don't usually use, because if this is more clicky for you, if this is clicking better, if this is making it easier for you to understand, then I want you to make it easier to understand. So I'm plugging in the y, the m, and then the x, and finding b. So this is 5 equals 4 plus b. Subtract 4 from each side. b is 1. Y equals negative x plus 1. Last one. Which one is a function? Identify each one that is a function. This one is not. This one is not. 6, 5, 1, 7. This one is. 0, 3, 3. This one is not. So, B and D. Last question. Okay, select the points that make up a relation with a range of negative 4, 1, 3. So we just need to look for the y values of negative 4, 1, and 3. So E would be in there. Negative 4, D. 1, C. And B is a 1, so B is in there too. But not A. So not A and not F, just B, C, D, and E. And I hope you're feeling confident about the exam. Email me if you have any questions at all. I will be around, except that I will be at some point taking a nap. Silver 4s, when I get your test grades put into PowerSchool, I will let you know. Enjoy the snow day, but make sure you're reviewing for your exam. See you guys in class.